Now to look at the reflection and translation of functions. So starting with reflection. Reflection can be asked in one of two ways. Now you can be asked to sketch the reflection of a graph in the x or y axis. You can also be asked to find the equation of a function when reflected in the x or y axis. Now to look at sketching graphs, just as a practical example, if we have something in this quadrant and we want to reflect it in the y-axis, we are basically going to treat the y-axis as a mirror and then draw the mirror image over like this. So any point over here should be over here, and a point over here reflects over here. And then similarly, if we want to reflect something about the x-axis, we are simply going to draw the mirror image about the x-axis. Okay, so now finding the equation of a function. When we reflected about the x-axis, we simply say let y equals to negative y. So in our equation, we're going to replace y with negative y, and then we're going to isolate y. And if we reflected about the y-axis, we make x equal to negative x. Wherever we see an x, we replace it with a negative x, and then we simplify our equation. Now, just to look at the practical side of this, if I have a point, let's say I have a point over here, my point is x and y, and I reflect this point in the y-axis, I'm going to change. So here it says if we reflected about the y-axis, we make x negative x. So we replace our x with a negative x. The y stays the same. And here you can see it. So this point, let's say this coordinate was, for example, well, let's make it simple. Let's say it was 2 and 6. Now this point will be negative 2 and 6, as you can see. And if let's look at an example in this on reflecting about the x-axis. If I have a point over here, x and y, and I reflected about the x-axis, I make my y negative. So this point will be x and negative y. So let's look at a practical example. Let's take this point. Let's say it is this point is at negative 2 and 2. So to reflect it, our x value remains the same as we can see here, but our y value will change sign. So where it was 2 here, it's going to become negative 2 over here. Alright, so now on the same set of axes, sketch the reflection about the x-axis for the following graph. Now, reflecting it about the x-axis, so whatever happens on this side of the x-axis needs to happen on the other side as well. Reflecting it there, and then if it goes up here, it goes down here. So this is the reflection about the x-axis. And then for the parabola, it would simply look like this. You can actually, if you get confused with this, just take it one part at a time, like this, treating this part, just reflecting that part, then reflecting this part, and then finally reflecting this part. And then moving on to the hyperbola, if I just treat this one, just reflect this one side over here, it would look like this. If I reflect this side, it would look like this. So my whole function reflected about the x-axis would then look like the blue one. And then for the exponential, I'm gonna divide this graph up and then just think about the one side for now. Okay, that's a bit high. But anyway, it looks something like that, and then it goes down for the other side, it just goes down. All right. So now reflection, finding the equations of the graphs when reflected about the x-axis. So remember, if I want to reflect in the x-axis, let's just write here, reflect about the x-axis. What happens is my y's will now become negative y. So if I start with my first one, I write it as y is equal to 3x plus 2. Then I just replace my y with negative y. So minus y is equal to 3x plus 2. And then the second step is to simplify or isolate my y. Let's isolate y. So y is then equal to negative 3x minus 2 when I divide everything with minus 1 to get y on its own. So this is then my equation reflected about the x-axis. Right, so next up we have a quadratic, so we write it as y is equal to minus 2x squared minus 4x plus 7. So we're going to replace our y with a negative y equals to 2x squared minus 4x plus 7, and then we isolate y. So y is equal to negative 2x squared plus 4x minus 7, because if we divide both sides by a negative, all our term signs simply change. Then for c, we have a hyperbola, so we first just write it in y equals to 2 over x minus 3 plus 1, and then we replace y with negative y equals to 2 over x minus 3 plus 1, and then we isolate y. So y is then equal to negative 2 x minus 3 minus 1. So this counts as one term, so I just add a minus in front of this first term and change the sign of this term. And then finally for d, we have our exponential, y equals to 2 times 3 to the power of x plus 1, and we replace our y with a negative y, and then we solve for y. So y is equal to negative 2 times 3 to the power of x minus 1. Find the equation of hx if h is fx equals to 8 to the power of x minus 2 reflected in the x-axis. So we want to reflect in the x-axis. That means that y will become negative y. So I write down my equation. Y is equal to 8 to the power of x minus 2. Then I replace my y with a negative y. And then I isolate my y as being minus 8x plus 2. But the question says the equation of hx, so the equation of h of x is equal to negative 8x plus 2. Now to reflect it in the y-axis, on the same set of axes, sketch the reflection about the y-axis for the following graphs. Now I'm just going to make it simpler, I need to reflect it around the y-axis, so whatever happens here needs to happen that side. So this just looks like that. On the bottom part, if I go that way, now I need to go that way, so this just looks like this. Please use your ruler. And then for the hyperbola, so once again I'm going to say I'm reflecting it about the y-axis. I'm treating this part first, so I'm just going to draw it like this, and then for this part over here we're just going to do the same here. See, this needs to be a reflection of each other, then it just goes up like this, so which goes that way now goes this way like that. Okay, and then for this one, reflecting it in the y-axis, so we go down like that when it reflects over there, and over here we just go up and it looks like that. Alright, and then finally for the exponential, so on this side we have this line almost straight, so we're going to do exactly the same here, and then over here we're going to draw it up like this, so reflecting it to this side. Okay, find the equation of the graphs when the following functions are reflected about the y-axis. So we want to reflect it in the about the y-axis. So this means that my x, wherever x is, x will now equal to negative x, or replace all your x's with a negative x. First one, a straight line. I have y is equal to 3x plus 2. So here I have my x. Now this is going to be y is equal to 3, replace it with a negative x plus 2, and then we just simplify it. So this is then going to be equal to negative 3x plus 2. So you see we just multiply these two out, which becomes negative. That term becomes negative. Then for a quadratic, y is equal to 2. Instead of x, so I'm just going to replace this with negative x. So instead of x, I write negative x minus 4, replace it with negative x. That's the only thing you need to worry about in the first step. And then we simplify. So this will then, so square makes this positive, so this actually stays the same. But this minus and minus multiplies out and becomes plus 4x plus 7. And then for C, we have a hyperbola. Y is equal to 2 over x minus 3 plus 1. Now here we've got this x, so I'm going to replace it with a negative. So 2 over minus x minus 3 plus 1. Now, to get this in its simplest form, I'm going to pull out a negative. So this is going to become minus, so 2 over x plus 3, because I factor out a negative from both of these terms, plus 1. And then I'm just going to rewrite it as y. This could be fine. This is fine for your final answer, but I'm just going to rewrite it as minus 2 over x plus 3, as we can see that the a value is now negative plus 1. And remember, when the a value was positive, it lies in the first and second quadrant. So over here, the a value was positive and we reflected it, so it now lies in quadrants 2 and 4. Alright, and then finally we have this, we have our exponential. So we have y is equal to 2 times by 3 to the power of x plus 1. So my x is over here. I'm just simply going to replace it with negative x. We have y is equal to 2 times 3 minus x plus 1. That's fine for its final answer, or you can change it into y is equal to 1 over 3 to the power of x plus 1, where this negative, so if you have 3 to the power of negative 1, you can just change it into 1 over 3, because you take the base down, right? You take the base down and then the exponent becomes positive, hence 1 over 3 to the power of x. So find the equation of hx if h is fx equals to minus 2x squared plus 3x minus 1 reflected about the y-axis. So if we want to reflect about the y-axis, then that means that wherever we see x, we need to replace it with negative x. So this this is where we will replace these x's with negative x. So we have y is equal to minus 2x squared plus 3x minus 1. And then wherever we see x, we replace it with a negative x squared and in brackets plus a minus 1. Now to simplify this, just when we square a negative number, it stays positive, becomes positive. So this is then just going to be positive x squared. Minus and a plus becomes a negative, so this is negative 3x minus 1. And then we have our equation as hx. So hx is equal to minus 2x squared minus 3x minus 1. Now when we have translations, if I have a function f of x and I say plus q, so this q represents a number, then this q will move my function up and down, as you can see here. Now for this example, if I have h of x, it will find h of x if h is f of x equals to x squared minus 3x plus 2 shifted 5 units down. So that means that h of x is equal to f of x shifted 5 units down, so minus 5. And therefore, if I want to find h of x, I can just say f of x, which is this is its equation. So I just substitute it in here. We have x squared minus 3x plus 2 minus 5. And then h of x is equal to x squared minus 3x minus 3. Now, the translation, the horizontal shift, if I'm given f of x minus b, what happens here is the graph is moved left and right. But one thing to note is that my P represents the shift. So if my P is, let's say I've got f of x, and I shift my P to the right, then it's plus 2. But because of this minus in the standard form, it's gonna look like it's the opposite way. So if you have a function, or if they give you x minus 2, it means it shifts to the right. If you have x plus 2, it shifts to the left. So find h of x. If h is fx, shifted 5 units right. So hx is then going to be equal to f of x, but then shifted right means we're going to subtract 5. So what we're going to do is we're going to find f of x, but we're going to replace these x's. Everywhere where we see x, we're going to replace it with x minus 5. So h of x is equal to, so we have, instead of x, I'm going to replace it with x minus 5. And then that's squared minus 3. And then in place of x, I'm going to replace it with x minus 5 plus 2. So to simplify this, here we can say we can expand these brackets. So be careful not to just take the 2 into each of these terms. That's a common error. But you can expand it, or you can just do the quick way where we say x, we square the first one, that's x squared, we multiply them together, multiply with 2, so it's minus 10x, and square the last one plus 25. With expansion, I mean that you write it as x minus 5, and then you just FOIL it out. But this one is much quicker. Then multiplying the minus 3, so this becomes minus 3x plus 15, and then plus 2. So now we just add the like terms. We have x squared over there, then minus 10x minus 3x is negative 13x, then 25 plus 15, that gives me 40, plus 2 is plus 42. The graph of fx is given. Determine the new equation of the graph if the graph is shifted 5 units left and 2 units up. So that means that my new graph, let's call it h, so hx, will be my graph f of x. So that would be f of x, but now f of x is shifted 5 units left. So left meaning I'm going to add 5 units to x, so x plus 5, and then it's and 2 units up, so I'm going to plus 2 for my q. So that's 5 to the left and then 2 units up. So just to substitute in this equation into what's happening here, means wherever we see x, we're going to replace it with x plus 5, and then at the end we're going to just take this whole thing and add 2. So we're going to write it as 2 over x plus 5 minus 1, and then plus 3. So here we simply replaced our x with x plus 5, and then for this 2 we just add 2 to this whole function. See, this whole thing represents f of x, and then we just simplify. So this is going to become 2 over then x, so plus 5 minus 1 is, so x plus 4, and then plus 3 plus 2 is plus 5. The graph of f of x equals to 3 to the power of x plus 1 is given. Write down the new equation of h of x and describe the translation of f of x if h of x is f x plus 3. So h of x is equal to, so this is a, is equal to f of x plus 3. So in this case, our graph has been shifted 3 units to the left. But all we need to concern ourselves about is we take our normal graph of f of x equals to 3 to the power of x plus 1. We replace x with x plus 3. So this is then going to be 3, and then instead of x we say x plus 3 and then plus 1. And then for b, we have h of x is equal to f of x minus 4. So here we have our f of x. F of x is this whole thing here, so we can just plug it in there. So we have then in place of f of x we have 3 to the power of x plus 1 minus 4, and then we just simplify that. We get 3 to the power of x minus 3. the graph of f of x is given, write down the new equation of h of x and describe the translation of f of x if A, we have h of x equals to f of x minus 5. Now what happens is we have our equation here and we want to replace, so this graph has been shifted to the right, so we have, wherever we see x, we're going to replace it with x minus 5. So this is going to be x minus 5. There we replaced our x plus, and then everything around that is still the same, minus 3. So this just simplifies to, if we let these drop these brackets because there's nothing here to multiply in, then minus 5 plus 2 will give us negative 3. So x minus 3 squared minus 3. So what has happened, if we have to describe the translation, f of x have been shifted, now if it's minus, it means to the opposite direction, so to the right, 5 units right. Okay, and then for b, we have h of x is equal to f of x plus 1. So to do this, we simply take our f of x. Our f of x is this whole thing over here, and we replace it in here. So we have x plus 2 squared minus 3, and then that plus 1 at the end. So this then becomes x plus 2 squared minus 2. And what has happened is f of x have been shifted. So this is 1 unit up, because that's the q value, have been shifted 1 unit up. The parabola has a turning point, a 3 minus 1. Find the new turning point if the graph has been shifted 3 units right and 2 units down. Now, in this, we can really just think about this practically. If we have a parabola like this, we shift the graph and we have our turning point here as 3 and minus 1. So first of all, 3 units right. So then we go right 3 units. If we over here, this x value changes to 6 because we add 3 units to it. And then on this point, 2 units down. So now we go down 2 units. So this means our y value is now from minus 1 going down further 2 units. So this is going to be 6 and minus 3. So that's one way to just look at it graphically. Or we could just say that our equation will be, we take the normal 3 and then 3 units right, so we add 3 to our x, and we take the y, which was minus 1, and it's been shifted 2 units down, so minus another 2, and then this will give us 6 and minus 3, as we saw previously. The parabola has turning point a, minus 2 and 7. Find the new turning point if the graph has been shifted 3 units left and 4 units up. So we have this point over here, turning point for our parabola. It's minus 2 and 7. Now, first of all, we shifted 3 units left. So it goes left 3 units. So that means if you're on minus 2, you go 3 back, and that leaves you at minus 5 and 7. And then 4 units up. So going 4 units up, if we add 4 to this value, we have minus 5 and 13. Or just algebraically, we could have said we have a, which is minus 2, and then we have 7 over here. So with the x, we're shifting 3 units left, meaning we're going back 3, and then we're going 4 up, plus 4. Now notice this is not like when we're going left and right inside the equation. This is the coordinate itself. So if you're going left and right with a coordinate, you just apply if you're going left, you say minus 3. If you're going right, you say plus 3. So, but when you're working with an equation, it's the opposite values, and then we can just say, okay, our new equation a dash is going to be minus 5 and 13.